Uh, Hello, Professor Thomas. Am I audible?
Yeah, good afternoon. Yes, this is Tomar here.
Yeah, good afternoon, sir.
Good afternoon.
So, I don't think many people have joined or anybody else is joining. Should I start, sir?
How many have joined so far?
Uh,
Three.
yeah,
Maybe you can wait for some more time, few minutes.
yeah, so I'm waiting for some minutes. So, you will be present throughout the session?
It is a 2 hour session, right?
Yeah, it is a 2 hour session. So, you will be present throughout the session?
Maybe for first half, first 1 hour.
Okay, in every session?
There will be such sessions again.
Sir, this is a TAship session, so I mean, you may have to be or may not have to be. It's not necessary for you to be present.
Yeah, as I found, no, I have been invited as a learner student.
Okay, okay,
I have registered as a learner also.
okay. So,
As a faculty, I have not received this. So maybe my presence is not needed. I just thought that in the beginning I'll join.
no, no, your presence is not needed because I have taken this TAship before. I mean, it's up to you, sir, but I have
Yeah,
taken
yeah,
this.
yeah. Perfect, perfect, perfect. Actually, I was just thinking, how is it going? Because this is the first time I'm seeing
Yeah,
problem solving session. So I was a bit curious to know what is happening.
yeah, sure, sir.
So it's fine. I mean, in fact, I have some other meeting at 4 o'clock.
Okay.
So you go ahead. But in case you have anything to ask me, you have my phone number?
No, sir.
Okay. So you can write down my phone number.
Yes, sir. Please.
Yeah, 98
98
205
205
64
64
125.
125. Okay, sir.
You can WhatsApp anytime, no?
Yeah, sure, sir.
So, and you can also write to me the progress, how the students study. In case you have some feedback from them,
Yeah, sure, sir.
you can write to me about the feedback. Or, now we cannot help because the videos are already online.
Yeah.
So the content cannot be changed.
Yeah, no problem, sir. Sir, actually, after recording, I have to put it on a YouTube channel, and then I have to have this live session discussion. And if they will be having some problem, they will mail me. And still, if there is some issue, then
Yeah.
I have to contact you. So
So
I
you
have,
can contact me.
yeah,
So right now I'm quitting.
yeah, sure, sir. I
Yeah,
have
yeah,
taken this TA shift before, so
yeah,
because
yeah. Oh,
in case nobody joins, sometimes it happens nobody also joins. Then I have to record the whole session and put it in a YouTube so that according to the
okay,
convenience,
okay.
people see it. Yeah,
Okay, okay,
sure, sir.
okay.
Okay.
Okay, best wishes.
Yeah. Thank you, sir.
And do inform me in case anything is required.
Okay.
Yeah.
Sure, sir.
Okay, bye bye.
Yeah. Nice. So, as it is already 3:05, hello everyone. Myself Shresh Gupta, and I am a third year PhD scholar in ISA Kolkata. I work in on material chemistry. So I will be a teaching assistant for the course of nuclear and radiation chemistry, being taught by Professor B.S. Tomar and Professor P.K. Mahapatra, HPNI. So in the assignment one, there will be 10 questions from the week 1 classes. If you have any question after the explanation or any doubt, please write in the chat box or send a mail, or after explanation you can unmute and also say. So in order to give a feedback of the course is being taken by Professor B.S. Tomo and Professor P.K. Mahapatra. The course outline is that this is based on a nuclear chemistry which deals with the nuclear properties of the elements using chemistry as a tool, and then later we are going to study radiochemistry here. So it's gonna help us in understanding the nuclear and chemical properties of the elements, the nuclear models, fission, fusion reaction, and the radiochemical practice, radiation detection, and most importantly, the chemistry of the actinides. So yeah, I guess you have already gone through the lectures. So if not, then let me tell you that uh, along with seeing the videos, you're also given access to download the lecture. So if you just a minute. Yeah. So if you have not downloaded these PDF, let me show you. Like this, you are also given the PDFs, and then This is how Professor Tomer has started the class. So I'm just giving an outline in a quick session, and then we will have some discussions if some people will be joining. So yeah, so the first thing is what is radioactivity. So that is already explained that it is a spontaneous emission of the ionizing radiation, which are alpha, beta, and gamma. Then what are isotopes, what are isobars, and then there are isotones also. Uh, Elements having same atomic number or same mass number, and then which are the radioisotopes. Then how did the radioactivity got discovered, then the group displacement law. I mean, if you have not seen, then you can ask me any question. I'm just giving a quick feedback so that when I'm going to present the assignment question, you will be able to grasp it more quickly. Why do even a radioactive atom decay? Why does it decay? Like, what is the need? Okay. And then isotopes, natural radioactivity, and artificial radioactivity. And then in the lecture 2, he has explained about the law, the mean life, and the kinetic study, and then the branching and all. Okay, so this is all related to the derivations. You can go through it once. How do we calculate the activity, the radioactive decay, and the mean life? These all are the first order reactions. So please go through them, and if you have any problem, then I will be more than happy to discuss it. Then there is radioactive decay chain reaction. Then how does a daughter product grow from the parent accumulation? Then Batman equation. All this, please go through them. Then in the other lectures, there are equilibrium, transient equilibrium, and then there is a secular equilibrium. So please go through them, the differences in between them, and then this generator, TC generator. Then application of radioactive equilibrium and the role of reaction in production of radioisotopes. In lecture 3, he has give a detailed description of discovery of nucleus, discovery of proton and nuclear radius. What is it? Nuclear charge radius and electromagnetic radius, nuclear force radius, nuclear density, and nuclear mass and binding energy. Please remember this equation, because in the assignment one there were a few questions which will require these equation. So yeah, nuclear mass and binding energy of a nuclei, and all this stuff. So these were the combined lectures which are being taught by Professor Tomer till now. And now I will be discussing with you people how I hope anybody has joined or not. Nobody is there, so it's okay. Uh, so no problem. I will be more than assisted. So I'll upload the whole recording in my YouTube channel. In case people join, it's okay. If not, then no problem. So okay, so this is a PDF for help. I'm just giving a quick session, that quick revision. So what is radioactivity? So it is a process in which nuclei of certain elements spontaneously disintegrate at a rate characteristic for each particular active isotope. Okay, and all the heavy elements from bismuth through uranium and also a few of the lighter elements possess radioactive properties. However, the radioactive property of different radioactive elements differs widely. Example, radium atoms have above about 3 million times the activity of uranium ions. So how this radioactive disintegration occurs? This radioactive elements can disintegrate any moment. During disintegration, atoms from new elements having different physical and chemical properties are formed, which are called as daughter elements. So in alpha emission, what happens? There is a parent element and there is a daughter element. So when an alpha emission is occurring, there is a change of 4 in atomic mass and there is a change of 2 in the atomic number. Example, uranium 92-238 disintegrates into thorium 92-34 with a 2He4. So what is alpha particle? A doubly charged helium ion. Okay. Beta means there is no change in the atomic mass, but there is an increment in the atomic number, and then there are elements which are having same number called isobar. Example is this, and then isotope example is this. So this is alpha, B, C, D. So elements having same number of protons, isotopes, same number of neutrons, isotones. And element which have some more additions are there. Elements which have same value of A minus 2Z, isodiphers, and elements which have the same number of electrons are called as isoelectronic. And compounds having same number of atoms as well as same number of electrons are called as isosters. So what is the law of radioactive disintegration? So atoms of all radioactive elements undergo spontaneous disintegration and form new radioactive elements. The disintegration is accompanied by the emission of alpha, beta, and gamma rays. Disintegration is at random. Every atom has equal chance for disintegration at any time. Okay, so the number of atoms that disintegrate per second is directly proportional to the number of remaining unchanged radioactive atoms present at any time. The disintegration is independent of all physical and chemical conditions like temperature, pressure, chemical combination, etc. The two laws of radioactive disintegration can be summed up as below. First, the first one is group displacement law, as being explained by Professor Tomer. The result of alpha beta particle changes that can be summed up in the form of group displacement law. What is law? In an alpha particle change, the resulting element has an atomic weight less by 4 units and atomic number less by 2 units, as we know, and it falls in a group of the periodic table, two columns to the left of the original element. And in a beta particle change, the resulting element has same atomic weight but its atomic number is increased by more 1 than its parent, and hence it lies one column to the right. So law of radioactive decay is like, according to the law of radioactive decay, the quantity of the radio element which disappears in unit time is directly proportional to the amount present. So determination of number of alpha and beta particles is emitted. This is the equation. We can know if there is x m n and then this y m dash n dash. So we can just put a alpha 2 before b beta minus 1 0, and then we can just balance this equation. We can find out. Now there are certain points to remember. Rate of decay is the number of atoms undergoing decay in the unit time. It is represented by minus dnt by dt. Now rate of decay of a nuclide is directly proportional to the number of atoms of that nuclide present at that moment. Hence dnt by dt is directly proportional to n, or dnt by dt equal to lambda nv. Okay, rate of decay of nuclei is independent of temperature, and since the rate of decay is directly proportional to the amount of radioactive nuclide present, so nt is equals to, we can see, n naught ne minus lambda ddt. By taking a log, we get to know into this equation. The final equation is this. Okay, where n naught is the initial number of atoms of the given nuclide at any time 0, and t is the number of atoms of the nuclide present after t, and lambda is a decay constant. Now decay constant is a ratio between the number of atoms disintegrating in unit time to the total number of atoms present at that time, is called decay constant of the nuclei. The characteristic of a decay constant is what? It is a characteristic of a nuclide. Its units are time inverse and its value is always less than 1. So mathematically, half-life period T half is equals to 0.693 by lambda. Now there is average life period. Since total decay period of any element is infinity, it is meaningless to use the term total decay period for radio elements. Thus the term average life is used, which is determined by the following relation. Average life T is equals to sum of life of nuclei, total number of nuclei. Okay, so T is equals to 1 by lambda. Substituting the value of lambda in the above equation, T is equals to T half over 0.693, which is 1.44 T half. Thus, just a minute. Okay. So there is an average life period, then there is a specific activity. Now this specific activity can be explained as rate of decay divided by m, which is lambda n by m, lambda cross Avogadro number over atomic mass in grams. Okay. Now what is the radioactivity? The phenomenon of spontaneous disintegration of nuclei. Generally it is exhibited with atoms with A greater than 192 and Z greater than 82. Lead isotope is a stable and product of any natural radioactive series. Radioactivity is a nuclear process and not an atomic process. Radioactivity is not associated with electron configuration of the atom. Now Rutherford's Soddy theory says that the n is the number of radioactive nuclei present in a sample at a given instant of time. Then the rate of decay at that instant is proportional to n. dn by dt equal to minus lambda n. If m naught is the number of radioactive nuclei, t equal to 0, n is n naught e raised to minus lambda t. Where if we plot a graph with n and t, it comes like this. The nuclear one is stable atoms decay spontaneously, emitting alpha, beta, and gamma particles. Now there is Soddy-Huygens law, which is already explained, and then comes the terms activity. The number of atoms of any material decaying per second is defined as activity of that material. Its value depends on the quantity and nature of the material. Units are becquerel. BQ, which is 1 disintegration per second. 1 Curie is 3.7 cross 10 is to 10 in disintegration per second. 1 Rudderpose is 10 is to 6 disintegration per second. A equal to formula are dn by dt, A equal to lambda, these all we have to remember. Then there is the formula of decay constant. It is equal to the reciprocal of the time in which the activity of the material reduces to 1 by E, or 37% of the initial activity. I don't think anybody has joined, so I will be uploading this video on the YouTube as the duty of following TAship. I need to do it, and then we can see what to be done. Okay. So going further, decay constant is equal to the reciprocal of that time in which the activity of the material reduces to 1 by E, or 37% of its initial activity. Lambda is equals to minus dn by dt over capital N. So number of atoms decaying per second over number of atoms remaining after decay is called the rate of disintegration per atom, or known as decay constant. Decay constant does not depend on temperature, pressure and volume. It depends on nature of material. Its unit is per second. Decay constant we can see from here. Then this value is to the negative of the slope of NT curve, and a decay constant of stable element is 0. Okay. Now we come to the topic of half-life. The time in which the number of atoms reduces to half of its initial value is defined as the half-life of the element, T equal to T half, N equal to N naught by 2. The time in which the activity reduces to half of its initial value is defined as a half-life. Its unit is second. Now certain formula, T half is equal to 0.693 over lambda log base C2 by lambda. T half is equal to log base C2 by log base 10 N naught by N. So T half is equal to T by N, where N equal to number of half-lives. So the time of disintegration is equals to T log base 10 N naught by N over 0.3010. Makes sense. Now there is a mean life. The time in which radioactive materials remains active is defined as mean life of that material. Tau is equals to summation of T dn over N naught. Now average time taken is decaying by the atoms of an element is defined as its mean life. Tau is equals to 1 by lambda. Its units are second, minutes, hour, day, month, year, etc. The magnitude of slope of decay curve is equal to the mean life. Relation between the mean life and half-life is tau is equal to T half over 0.693, tau equal to 1.44 T half, or tau is greater than T half. Makes sense. There are certain important formula related to this law of disintegration. N equal to N naught E lambda T, A equal to A naught E raised to minus lambda T, M equal to M naught E raised to minus lambda T. Then this you have to remember. Now there are certain hints. So yeah, I will share all these notes with you people. Now there is nature and value of charge. So alpha is positive, beta is negative, gamma are neutral, and then nature of the particle, doubly ionized, electron, electromagnetic waves, mass, specific charge, then how does they are explained by tunneling effect, neutrino hypothesis and all this stuff. Ionizing power, velocity, mutual interaction with matter. Now characteristics of alpha rays, the range of alpha particles, how deep they can go, and then relation between alpha particle and their energy. Characteristics of beta ray and how deep they can go. And then there is neutrino hypothesis. What is neutrino hypothesis? According to Pauli, whenever neutron is converted into proton, or proton is a neutron, then this process is accompanied with the emission of a new particle, to which he named as neutrino, which is 1p1 0 and 1 plus 1 e0 plus mu. 0 and 1 equal to 1p1 plus e plus v var. So the properties of this is what a neutrino is, nu var. What are the properties? The charge on neutrino is 0. Okay, the rest mass of neutrino is 0. Its spin angular momentum is plus minus h by 2. Its speed is equal to that of light. It has finite magnetic moment, but the magnitude is very small. Its antiparticle is anti-neutrino. The linear momentum vector and spin vector are mutually in opposite directions. Its energy is equal to E and minus E beta. It does not interact with matter. Neutrino was discovered by Pauli, and its experimental verification is done by Reines and Cowan. Characteristics of gamma rays. The spectrum of gamma rays is a discrete line spectrum. Whenever alpha or beta particles is emitted by a nucleus, then a daughter nucleus is left in the excited state. It suddenly makes transition in the ground state, thereby emitting gamma rays. Knowledge about nuclear energy level is obtained by gamma spectrum. Gamma ray interact with matter as a consequence, which the phenomena of photoelectric effect, Compton effect, and pair of production happens. Intensity of gamma rays is it penetrate matter, and then the intensity decreases exponentially. The thickness of the matter at which the intensity of gamma rays reduces to half its maximum value and is known as half value of thickness. The reciprocal of the distance inside matter at which the intensity reduces to 1 by E or 37% of its maximum value is defined as a coefficient of absorption of that material. Coefficient of absorption mu equal to minus di by I over dx. Mu depends on the wavelength of gamma rays and the nature of the absorbing material. There is a radioactive series, 4n plus 2 series, 4n plus 3 series, 4n series, and a 4n plus 1 series, and 4n plus 1 series is the artificial series. How to calculate alpha beta particle I have already explained. I will share all these notes. Then isotopes, isobar, isotone differences, radioactive isotopes, uses of them in medicine, in archaeology, in agriculture, at races, industries, research, etc. So I'll share these notes and this combined lectures PDF with you in case you have missed. After that, now let's come to the assignments. So yeah, I've already introduced myself. If you have any doubt regarding any question, feel free to email me. The email is sd19ip011 at the rate eithercoal.ac.in. So from week 0 assignment I have taken certain questions, some questions I have made of myself, and some questions I have taken from week 1 assignment, that in case how will you solve, what are the right answers. So yeah, from week 0 assignment, 3 questions I have taken as a one question. Okay, so this is 1A, 1B, 1C. So now the first question is saying radioactive decay follows the rate law S. So we know it very well. Radioactive decay is always the first order kinetics, so answer should be the first order. Now, the radius of a nucleus varied with the mass number as a raised to the power 1 by 3. We know it very well. Okay, the heaviest element that is stable till now is lead. We know. So these are the answers. Now let's going to the second question. The week 0 that was for the practice session. Elements having Z around 114 and around 184 expected to have extra stability and called as what? Second question is the first experiments towards synthesis of transuranic elements were carried out by whom, and the heaviest element that has been discovered to date has atomic number what? And as nobody is here, I am not obliged to wait for anybody. I'm so sorry. So I will tell the right answer myself, and the right answer is magic number elements Enrico Fermi and 118, which is also known as an odium. Okay, now let's going to the next question. In which reaction the kinetic energy is conserved? Elastic, inelastic, direct, compound nuclear reaction. 238U is the first member of which natural radioactive series? Atom with different atomic number but same mass number, and atom with uh, neutron number but different mass number. The answers are, we know, elastic scattering, but 4n plus 2 isobars and isotones. Okay, now there is a question. These are the questions which I have made myself, which will help you in solving the assignments. Now consider there is a reaction 92x234 plus beta plus alpha giving y plus gamma plus 2 beta positive. Y is what? Okay, so just a minute. I let me see. Nobody is joining. I don't know what should I do, but still I will present this. My PPT I'll present. So yeah, so the answer to this will be, with an addition of an alpha particle, we know atomic mass get increased by 4 and atomic number get increased by 2. So with addition of beta particle, atomic number get decreased by value of 1, and the release of beta plus particle, atomic number get decreased by 1. Okay, just a minute. So hi Shanvi, am I audible? Hello.
Hello, sir. You are audible. Yes, sir.
Yeah, so you have joined a bit late. I have already started it. So nobody joined. Professor Tomar was here. So yeah, so Just a minute. I'm giving you another just a quick. You are a registered student into this course, right? In the NPTL.
Yes.
Okay, great. So I hope you have seen the videos.
Yes, sir.
Okay, so basically this is regarding the week 1 classes, Shanvi. So in the week 1 classes, what have been explained, I have already explained in the video. Right now, I was explaining when Professor Tomer was here. Along with that, I have made a PDF in the terms of short notes of 10-12 pages, which talks about all of the things that have been taught till now. So I will share. I have already explained this before you're joining. So if you will be having any issue, Shanvi, you can write to me. So basically, my name is Shresh Gupta, and I'm a third year PhD student at IISA Kolkata, and this is my email ID sd19ip011 at the rate isacol.ac.in. Okay, except that this is a YouTube channel also, which I am sharing in the chat box, where I have to upload the videos. Yeah, I think I'm not able to copy. Just a minute. Uh, yeah, okay. So these all videos will be recorded and uploaded there also. So now going straight forward to this session. So Shanvi, you are there. So I hope you have gone through the week 0 and week 1 assignment, right?
Yes, sir.
Okay, so now let's go one by one and then we will see. And if you have any doubt, then we can see. Please go through the PDF later on, because I won't be able to explain the complete again now because you have joined a bit late. So I am starting with the assignments. So there are around 10 questions. These are week 0 assignments. So these 3 questions I have considered as 1A, 1B, and 1C. So yeah, like just for a quick revision, I have already explained anyways. So radioactive decay follows a rate law of what? Do you know it? What could be
No,
the?
sir.
Okay, so in the kinetics, radioactivity always follow a first order kinetics. Okay,
Okay.
so the right answer is the first order. And the second question is, the radius of a nucleus varied with the mass number as what? Okay, just a minute. If such is the case, then for you, I will give again a quick revision to you. Uh, okay, great. So, Shanvi, we know what radioactivity is. It is a process by which a nuclei of certain element is spontaneously disintegrate. Okay. Now, there could be disintegration in the form of alpha, beta, and gamma particles. So, what happens when there is a disintegration of alpha particle emission? The parent atom, there is a change in the atomic number of 4 and the mass number of 2. Example, uranium 92 238 disintegrate into thorium and 2He4. In beta particle emission, there is a addition of atomic number plus 1. Okay, example is this. So then we know what are isotopes. Elements that have same protons are called isotopes. Elements which are having same neutrons are called as isotones. And elements that have the same value, isodiaphers, and which have the same value of electron are called as isoelectronic. I will be sharing this PDF video. Okay, just for like a quick
Okay.
just for a quick revision of you. Then Professor Tomer has already explained in his class what is group displacement law. Please go through it. What is law of radioactive decay? Now, how do we calculate the number of alpha and beta particles? I will be solving some question in front of you. There are certain points to remember. From here, we find out that this is the first order kinetics, and this is the equation of calculating the decay constant. So then there is half life, average life, and then specific activity. All these things are there. So I will share this anyways. Then what is this phenomenon? Why does it actually happens? And then there are certain laws which you have to go through it. What is activity? What is decay constant? And then half life, mean life, and there are certain important formulas that you have to remember. That how do you calculate number, lambda, and all these things. Now there are certain useful hints. So all this I have made. So I will share, and then the characteristics of alpha, beta, and gamma rays, alpha emission properties, beta emission properties, neutrino hypothesis, and gamma emission properties. And then there are certain series, 4n plus 2 series, 4n plus 3 series, how these series are there, and which of them is natural and which of them is artificial. All these things, please go through them. Units, then isotopes, isobars, and isotones already. Radioactive isotopes and the uses. So I have made the PDF. I have already explained before you joined. So I have just given you a quick thing that what could be the possible things. So there are certain questions. So all these questions are covered into this PDF, by the way. So in discussion with you, I can explain you like this, that radius of a nucleus varies with the mass number as what? Now can you explain it? Do you know the answer? Okay, no problem. The right answer is a raised to power 1 by 3. So mass number is the cube of the radius of the nucleus generally. And the heaviest element that is stable till date, Shanvi, is the lead. All these elements, bismuth, thorium and uranium, all these elements, no, these disintegrates. They show the radioactivity, but lead does not show. Okay, now let's go here. Elements having Z around 114 and N around 184 are expected to have extra stability and are called as what? Any idea, Shanvi?
No, sir.
Okay, so okay, this is a week 0 assignment, so I'm just giving you the answers. After that, I made some questions of myself, so I'll discuss with you so that you have a quick revision. Okay, so these all called
Okay.
magic number elements. Just to tell you the answers of the assignment, the first experiment towards synthesis of transuranic element was carried by Enrico Fermi, and the heaviest element discovered to the date has atomic number of 118, which name is unodium. Okay, other questions are like this: in which reaction the kinetic energy is conserved? Elastic scattering. 238 uranium is 4n plus true. Atoms which have same atomic number and same mass number are called as isobars, and same neutron number are called as isotones. This was a week 0 assignment. Just to tell you the solution, I have told you. Now let's go through the question which I have solved. Okay, now Shanvi, this question you have to solve with me. Okay, now consider this nuclear reaction where this x90 to 234 plus beta plus alpha is there, which is giving y plus gamma plus 2 beta positive. Now what is y? Can you tell the answer? I'm giving you 3 minutes. Shanvi,
Yes, sir. Yes, sir. I'm here.
okay, do you know how much do we have to subtract when we calculate the alpha and beta? Like what is the change in atomic number and mass number? I just now told you.
Yes, sir.
And if you are still facing difficulty, you can follow this equation, like this, just for your bit. But remember, this was beta positive. So like this you can calculate. Suppose this is x, this is y, x alpha plus y beta. So alpha is always 2he4, beta is this. So put is x and y and then equate it like this and solve it, if you can do it. I'm giving you 3 minutes, and if you are not able to do it, I'll tell you the solution, don't worry, because in assignment 1 we have some question of this type. We can see that a equal to a1 plus 4x, z equal to z1 plus 2x minus y. Now all these equation you have to solve, and then you get the value of x and y, which are the number of alpha and beta particles. Like this we solve. Will you be able to solve it, or should I tell you the solution, Shanvi?
Yes, sir. Please.
Okay, fine. So what happens, Shanvi, with an addition of an alpha particle, the atomic mass increase by 4. Okay, okay, and
Yes, sir.
with an atomic number increase by 2. So what happens with an addition of beta particle, atomic number gets decreased by the value of 1, as I have already explained.
Yes.
but with the
Hmm.
release of beta plus, particle number, atomic number gets decreased by 1. Okay, it happens
Okay.
opposite. So what happens, there is atomic number of y, 234 plus 4, which is 238. As we can see that all due to addition of alpha, alpha is adding here, right? Alpha is adding
Yes.
here, that means atomic mass will increase by 4. That means y
4.
should be having atomic mass of what? 238.
238.
Agree? Okay.
Yes, I agree.
Okay, then there is this 92. Okay, which is the
Hmm.
atomic number. Now this is beta, which is getting emitted, and it is giving gamma plus 2 beta positive. So due to the beta emission, there is a negative sign which will come here, 92 minus 1, because within beta the atomic number get decreased by 1. Okay, and
Yes.
this beta positive is called as positron. So this is on the other side, plus 2, plus 2 beta positive. That means this beta is giving 2 beta positive. So atomic number will decrease by 1, and further due to the release of 2 beta positive, which is positron, we will subtract 2 more from here,
Okay.
and 2 due to the addition of alpha in the atomic number.
Okay.
Just a minute, let me tell you why this. So what is happening, Shanvi? There is an
Hmm.
alpha particle, alpha and beta on the left side. Okay, so we have to see atomic number and atomic mass. Okay, now we
Okay.
know when there is an alpha particle, there is a change of atomic number by 2, and there is a change of atomic mass by 4. Okay,
Yes.
and when there is a beta particle, there is a change in atomic number by 1, as you can see here. Okay, and
Hmm.
if there is a positron, then there is a change of addition of atomic number to the side where there is a positron. Now if this beta positive would have been here, then we would have added it instead of subtracting. Okay, so now what we have to do,
Okay.
we have to calculate the atomic mass and atomic number separately. Okay, so now let's see, there was an element which is x. Okay, so x was having, let me add a new slide. Okay, so x was having atomic number of what? X atomic number was how much? Shanbi, tell me. What was the atomic number of x? Atomic number of x was
Two-
234.
92. 234. Yeah.
Atomic mass was 234. Atomic number was 92.
234.
Okay.
92.
Yeah.
Yeah.
So now we can see that if there is a change of atomic number, there is an addition of alpha particle and beta particle
Hmm.
on the left hand side. Now let's consider the atomic mass first of all. So atomic mass of x was 234. Okay,
Hmm.
now
Yeah.
234. Now there is addition of alpha and beta. So beta does not change any mass, but alpha change a mass by 4 units. So what will happen?
Yes.
234 plus 4. So one thing is sure, that it will be 238. Though
238.
the final species will be having atomic mass of 238. That means C is eliminated. Not a possible answer could be A or B or D. Okay.
Yes.
Now
Huh.
let's see the atomic number, Shanvi. Now coming to the atomic
Okay.
number 92, now we have to equate. If there is a addition of beta particle, the atomic number decreases by 1. Okay, now
Okay.
there is two positron on the right hand side, which for equating you have to subtract, and then also there is an addition of an alpha particle from here on the left hand side, for which you have to add 2, because when there is an
Yes.
alpha emission, there is a change of atomic number of 2 and mass number of
2.
4. Now
4.
considering the atomic number, let's see, considering the atomic number. Okay, so if we
Hmm.
consider the atomic number here, Shanvi, there is this
Hmm.
92 was initially here. Okay, now
Yes.
there is a beta particle which is added. So for which there will be a change of 1. That means 92 minus 1. Is it clear?
Yes.
Okay.
Yes.
Now,
Yes. Yes.
now there is a disintegration of two positron particles. So there will be another change of two atomic number. Okay.
Okay.
But there is an addition of alpha particles. Suppose if alpha would have been on the right hand side, then we would have subtracted 2. Okay.
Yes.
But it is on the left hand side, because in the mass number also we added, you remember, 234 plus 4 is
Mm.
238. So in the atomic number also
238.
we will add 2. So now you tell me,
Yeah.
minus 1 for this beta, minus 2
Mm.
for this beta positive, and plus 2 is for alpha. 92 minus 1 minus 2 plus 2. Minus 2 plus 2 get cancelled.
91.
This is
Mm.
91. So the
Yeah.
resultant nuclei will be Y with an atomic mass of what? 238, and but atomic number of what? Atomic number will be 91
91.
minus 1 plus 2 minus 2. It was not 90, it was 92, right? Yeah.
92.
Yeah.
Yeah. 92.
Yeah. So what will be the value? This 2 and this 2?
91.
91. So the correct answer is Y is 91 to 38, which is which option?
Mm.
Which is which option? Tell me what is the right
B.
option.
B of
Huh?
B.
Yeah, okay. B. Now you have same kind of question in assignment 1. If you will see, you will get to know that
Mm.
there is some alpha and beta particle emitting, and then you have to tell the like how many alpha and how many beta particles are there. And still, if you are not able to clear, Shanvi, I have told in how do we calculate alpha and beta particles. Here also and above also I have told that how do you calculate. So there are certain examples also, you can go through it. It's a 10-12 page thing. In short notes I have explained here. Okay. And
Okay. Okay.
still if it is not clear, then you can write to me the question and I can tell you the solution. Okay.
Okay.
Now going to the next question. The next question is this, Chanvi. So for a given nuclear fission reaction of uranium, there is addition of neutron which is giving barium, krypton, and this neutron. The amount of energy in kilojoule per mole released during this process is given. Uranium is having uranium is having atomic mass of this, barium is having this, krypton is this, neutron is this. I am pretty sure that you have not gone through the notes till now, right? The classes.
Yes, sir.
Okay, so no problem. Let me show it again for you, because you are the only one here right now. If there will be more people, I would not have gone into this again repetition. So these all are the classes which sir has already taught. So this is how we calculate it. See, there is nuclear mass equation mza, which is zmh plus nmn minus b, where b is the binding energy, and which is what energy released by jet proton and neutron which combine to give the nucleus. Higher the b, lower the mass number, more stable is the nucleus. This is one thing to explain why do radioactive atoms decay. Okay, in our case what is happening, uranium is disintegrating. Now in order to calculate the energy, how what we have to do, sir has already taught in his classes. Let me show you. Okay, these are the units of radioactivity, by the way. Just a minute. Hmm. Yeah. Okay, so here comes the nuclear mass and binding energy. So if you can see, the mass energy relation is E equal to mc square. Mass of hydrogen is this, neutron is this, and electron is this, which are the addition masses. And you remember the equation E equal to mc square. So 1 AMU is 931 mega electron volt. How this comes? You go through it once, and then this is the equation that we have to follow for our question. Nuclear mass and binding energy. What happens? Nuclear mass mza equal to zmp plus a minus zmn minus b, and nuclear binding energy is this, which is what, mc square. So whole nuclear mass into c square, which is c square is the velocity of the light. So this formula we have to use, okay, and then calculate it. Now let's see what is the question saying. The question is saying, Shanvi,
Yes.
yeah, key for a given nuclear fission reaction, this uranium is disintegrating into barium, krypton, and this neutrons. Okay, we can see. So they are asking us the amount of energy in kilojoule per mole released during this process when they have given the masses of this, and this. So as it is already taught in the class, that how do we calculate this formula, we have to tell this, we have to know. And still if you don't know, I will explain it again to you. So what is happening, let's see now. We know the energy per atom is delta mc square, right, Shanvi? Right now I showed
Yes.
you. Okay, now what is
Yes.
happening, let's see what is happening. This uranium is changing into barium, krypton, and neutron. So if we see, the mass of the uranium is 235.0439 atomic mass unit, barium is 141.9164, and krypton is 90.9234, and neutron is 1.00866. So we will directly put into this question delta mc square. Okay, so what is happening, let's see now. This uranium is adding, one neutron, right? You can see, okay,
Yes, sir.
on the reactant side. So in the reactant side, 235 will be added to the neutron. You just consider this half. This half only I am saying you to consider. Only this half. You you do not consider this one. You just consider this. On the reactant side, this is adding. Uranium is getting added to the neutron. This means uranium mass plus this mass, right? Reactant.
Yes. Hmm.
Okay, great. Now you have to come to the product side. Product side is having barium 141.9164, okay, plus krypton
Okay.
90, plus 3 neutron, which is 3 into this, right?
Okay.
Okay,
Yes.
great. Now in order to have this mc square, now in order to convert it, this is amu, we have, in order to convert it into kg, we have to multiply it by 1.67 into 10 raised to the power minus 27, okay.
Okay.
And then the speed of light is, we know, 3 into 10 to the power 8 meter per second, right?
Yes.
So delta mc square will be the energy on the reactant side minus the energy on the product side, that is a change in mass, which is a change in mass in the reactant side, change in mass on the product side, which is delta m into c square. Delta m will be what? Delta m will be what, Shanvi? Just again I'm telling
It's
you. Delta
masses of all.
mass on the reactant side,
Yeah.
mass on the product side, all.
Yeah.
And because it is an AMU, okay, so
Mhm.
we will convert it into kg, okay. So we are multiplying
Okay.
it into 1.67 into 10 raised to the power minus 27.
Acha. Okay.
Yeah, yeah. Then if how this relation is coming, you please go through it. If not, still this is a very basic thing, okay. So this is what we are doing. So as we can see here, that mass of the reactant minus mass of the product into this into c square, which is the speed of the light, this will directly give us the energy in joules, okay. So
Okay.
just a minute, just a minute, I'm so sorry, I don't know how to stop the notification of WhatsApp. Just a minute. Okay, so mm, Just a minute, Shanvi. Okay, Shanvi. So sorry for the interruption. I just muted my WhatsApp. So yeah. Now, so we know that this is there in a speed of light, which is three. You are seeing here, Shanvi, or not? Hello.
Yes, yes.
Yeah.
Hello.
Yeah,
Yes,
yeah.
sir.
So we know that 1 AMU equal to 1.67 cross 10 to the minus 27 kg, and the speed of light is this. So this will give us the energy in joules. So if you will calculate all this, you will get this as 2.8 cross 10 to the minus 11. Now there is one more thing. The question is saying the amount of energy released in kilojoule per mole. Now this is energy coming in joules. Now for per mole, we know how many particles or atoms are there in 1 mole. What is an Avogadro number? Do you remember?
No, sir.
Okay, an Avogadro number is a number of atoms in a mole, which is Na. So for per atom, this is energy what we have calculated is for per atom. Now for number of atoms, how many? 6.0223 into 10 to the power 23, because we have to calculate the energy in kilojoule per mole. So we have to multiply it by this. When we will multiply it, we will get the energy in joules. 1.68 cross 10 to the power 13 joule. Now to convert it into kilojoule, we will divide it by 1000, which is 1.67 cross 10 to the power 10 kilojoule. So the right answer is D. Again, I'm explaining to you because these kind of question you will be having in your exam. Only the values will be different. So I am explaining to you. So what is happening? First of all, AMU have to be converted into kg. Okay. So
Yes.
for 1 AMU is 1.67 into 10 to the minus 27 kg. Speed of light we know. We have to calculate the energy on the reactant side and on the product side separately. So for that, what we calculate? We calculate delta mc square. So this is a delta m, which is there as I am seeing here. Okay. So
Okay.
this is delta m, we convert it into kg, so we multiply it by 1.67 into 10 to the minus 27 like this, and then we have this. Just a minute. Yeah. So now we have to multiply it by the speed of light, which is what? 3 into 10 to the power 8 meter per second square. Okay. Now whatever energy we will be getting from here, Shanvi, it will be okay. This will be in what unit? This will be in joules, and this will be for one atom. Okay, you
Okay.
get. Now we are have to get the amount of energy in kilojoule per mole. So 1 mole has Avogadro number of particles. Okay, so what is Avogadro number? 6.022 into 10 to the power 23. So for energy of per atom, we have to multiply it, then we will get the value as 1.68 into 10 to the power 13 joule. Okay, Shanbi. Now in order to
Yes.
convert joule to kilojoule, we have to divide the joule by 1000, right? That means the
Yes.
power of 10 raised to the power 13 will go to 10 to the power 10. This is the right answer. Now, can you solve these kind of question if it comes?
Okay, I can try.
Okay, no
Because
problem.
I'm not, my background is not math, so it become difficult for me.
I understand. It's okay. It's okay. That's why I'll share all these slides with you. Don't worry. Okay, for your better fitment. Assignment one you have not submitted.
I have submitted.
How did you do it this time?
No, I kept it as option.
Hmm. Okay. 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 Now let's go to question number six. Question number six is saying that there is a fission of uranium which releases the energy of 200 mega electron volt. So in one day fission of 1 kg of uranium will give power how much approximately? So 1 mega electron volt is 10 raised to the power 6 electron volt, and 1 megawatt is 10 raised to the power 6 watt, and 1 electron volt is 1.6 into 10 to the minus 19 joule. These things you have to know. Shanvi, there are units
Yes.
kilo, mega, giga, tera, peta, exa. So kilo,
Okay.
okay. So kilo is 10 raised to the power 3, kilo, mega is 10 raised to the power 6, giga is 10 raised to the power 9, then kilo, mega, giga, tera 12, peta 15, and exa is 80. Okay. Now the question is saying that there is a uranium atom which releases energy of 200 mega electron volt, which means it releases energy of 10 raised to the power 6 electron volt. Okay, just a minute. Somebody is, I
Okay.
think, trying to join. Oh, he requested and then he went away. Let him try again. I don't know. Okay, so now let's see this. So if we will see it like this, so mega electron volt, megawatt, and 1 electron volt is this. Now, one uranium is having this energy of 200 mega electron volt, which is 2 cross 10 is to power 8 electron volt of energy released. Now, they are asking the question in one day of uranium fission of 1 kg of uranium, how many power in megawatt will be done approximately? Now, first of all, uh, Shanvi, we need to calculate
Mhm.
energy in watt, then we convert it into megawatt. Now, for converting energy into watt, first of all, we need to calculate the number of atoms in 1 kg of uranium. Just a minute. Hello, Sameem. Am I audible to you? Hello. Okay. Anyways, no problem. I am explaining. If you're not able to speak, I am already explaining to Shanvi. So in this question, Sameem, what we are doing, we are trying to calculate. Could you? Okay, we are trying to calculate. The question is this: the in fission of 235 uranium atom of energy releases 200 mega electron volt. So in one day of fission of 1 kg, uranium 235 will give power approximately. Now there are certain things which we have to put into our notice. The first thing is this: ki uranium, we are talking about one uranium atom which is giving energy of this, and we have to calculate the energy for 1 kg. And the energy, remember, this energy is given in mega electron volt, and we have to tell the unit of power in megawatt. So one thing I hope you know, that this is, there are certain units: kilo, mega, giga, tera, peta, exa. Kilo means 1000, that is 10 raised to power 3, mega is power 6, giga is power 9, tera is power 12, beta is power 15, and exa is power 18. All these videos will be uploaded on YouTube. All these notes, whatever you have missed previously, will be shared to you. You can see them. And still, if you feel any problem, Sameem, just for you, I'm sorry, Shanvi, you have to wait. You can email me on this email ID if you face any kind of issue. These questions I have already discussed. Shanvi was there. This was your week 0 assignment. And then this question I have already discussed. Just a minute. I think some more people are trying to admit. No, no problem. Okay. This question I have already discussed, that how to calculate the alpha and beta particle, and then this question I have discussed that how do you calculate the change in energy, that is the binding energy, and this is from lecture 3 of Professor Tomar. This is the question that I am discussing now. So Shanvi, you're there, right?
Yes, sir.
Okay, so let's move forward. Shamim is not speaking. So now for one atom, the energy is given in mega electron volt. That means for one atom, the energy is how many? How much? 200 into 10 to the power 6. That means 2 cross 10 is to the power 8 electron volt. Okay. Now we are given how much of amount of uranium? This is 1 kg of uranium. Okay, Shanvi.
Yes, sir.
So 1 kg means how much gram of uranium? 1000 gram, right?
Yes.
So in 1000 gram of uranium, how many atoms of uranium will be there? How will you calculate? We have to multiply 1000 with the Avogadro number, which is Na. Right now I told you,
Okay.
right? So
Six.
the
Yes.
total number of atoms will be 1000 gram into 6.022 into 10 to the power 23. That means number of atoms are 2.56 cross 10 raised to the power 24 atoms. So these are the number of atoms, and this is the energy for one atom. Okay, this is the energy of one atom. Now what will be the energy for these many number of atoms? This into this. 2.56 cross 10 raised to the power 20 atoms of uranium will give the energy of 2.56 into 10 raised to the power 24 into 2 into 10 to the power 8 for one atom. This is coming how much? 5.12 cross 10 to the power 23. Now, Shanbi, what is power?
Yes.
Power is the energy released per unit time. This is the energy which was released. Okay. Now, power we have to calculate in per second. That means joule per second is the unit which is equivalent to watt. Now, this is the energy that we know. Now, we have to calculate this energy per unit second. Now, in order to calculate the unit per unit second, we need to convert the hour into second. So, in one day, how many hours are there? 24. In 1 hour, there is 60 minutes, and in 1 minute, there are 60 seconds. So, power equal to energy release over time. This is the energy that we have calculated. This is time. When we will divide it by this, we will get the value of 5.926 cross 10 is to the power 27. This is coming as joule per second. Okay.
Okay.
So in order to convert the electron volt into joule, we will multiply by 1.6 into 10 raised to the minus 19. So this will convert it into joule, which is 9.481 into 10 to the power 8 watt. Now how will you convert it into megawatt, Shanvi?
Into 10 raised to 6.
No, that is when you have to calculate the megawatt to watt. Now you are doing it
Okay.
reverse. Suppose you have 1000 gram. How will you convert 1000 gram into 1 kg? By dividing it by 1000, right?
Yeah. Yeah.
But when you convert from kilogram to gram, you multiply by 1000. Similarly,
Yes.
when you have to convert watt to megawatt, you have to divide it by 10 raised to the power 6. That means you have to multiply by 10 raised to the power minus 6. So the answer is
Okay.
948.16 megawatt, which is C, 950. Again, Shamim, for you, this is a question where uranium is doing fission. Again, somebody is trying to join. People are joining late. So this is Gauri. Hi, Gauri. Am I audible to you?
Yes, yes, sir.
Okay, so as you have joined late, let me tell you, this is my YouTube channel. This video which is getting recorded, this will be uh, uh, just a minute. This video will be shared there on this channel. So you can see the video later on this channel, and after this all this I have made some short notes on the basis of week 1 classes. All this also I will be sharing in the drive, so all this you will get. And just for Shamim and you, I'm telling again that this is my email ID, sg19ip011 at that is isaaccole.ac.in. I'm a third year PMRF scholar at Isaac Kolkata, and I'm your TA for this course. Every week Saturday 3 to 5 I am having classes, and this will be the same Google Meet link that you have to use. So this week 0 assignment I have already discussed with Shanvi, and then I have made some questions by myself. The first question was, how do you calculate the alpha and beta particle? Already discussed. If you want to, if you have some problem, go through the video again, and then still if you have problem, email me. Secondly, this question I have discussed where I have calculated the change in energy. This third question I was discussing right now. So this question I am again revising just for the sake of you. Am I audible to you, Gauri?
Yes, sir.
So this question, what was it saying? Previously, you can see the video recording in the YouTube channel, and also the data. This PPT I will be sharing. So in this question, what is happening? This uranium is releasing, per uranium atom, it releases an energy of 200 mega electron volt. So in 1 day of fission, 1 kg of uranium will give in how much power, and we have to tell in megawatt. Certain things are there. The energy is in mega electron volt. This is saying in 1 day how much energy will be released in megawatt. First of all, mega means 10 raised to power 6. Okay, we have to calculate energy in megawatt, and in 1 day how many seconds are there we have to know, and then we have to calculate the number of atoms in 1 kg of uranium, and then the energy per atom, and then number of atom in 100 gram of uranium we have to multiply. So what we have done, Gauri, for one uranium atom, this is the energy released. Okay, now we calculated the number of atoms. So the number of atoms in 1 kg of uranium is 2.56 cross 10 raised to power 24 atoms. You are listening or not, Gauri?
Yes, sir.
Okay, if you have any problem, ask me in between. So for one atom, we know the energy is this much. So for these many atoms, the energy will be the multiplication of these two. Clear? This we calculated. Now the power is the energy released per unit time. In 1 day, how many seconds are there? We calculated, and the power what we get is 5.926 cross 10 raised to power 27 electron volt per second. Now in order to convert the electron volt into joule, we multiply this by 1.6 into 10 raised to power minus 19. So this comes as joule per second. Now joule per second is watt, and in order to convert the watt into megawatt, we divided it by 10 raised to power 6. So the answer is 948.16 megawatt, which is option C. You can note it down. Still if you have problem, I explained it very much faster because already 2 times I have explained for Shamim and Shanvi. So for you I explained, I repeated this for the third time, so I explained a bit faster. But still if you have any problem, you can ask me later. You can note it down if you want, and then we can move to the next question. Gauri, do you have any doubt?
No, sir.
Okay, makes sense. Okay, this question is there for you. So this question I'm not going to tell the answer. You have to tell me the answer. So the question is, initial weight of cobalt 2760 with T half equal to 5.27 years is 1 milligram. The amount of disintegrated in 1 year will be what? And the options are this. So tell me the answer now. I am giving you 5 minutes. If you can solve this question very well, if you cannot solve this question, I will tell you the answer anyways. Just remember, you have to make use of these equations. Mm. Yeah, this is the equation that you have to make use of. N raised to equal to n not e raised to a minus lambda t, and lambda is calculated by this equation, and you have to calculate it. So I have already explained all these things. So if you still have some problem, then we can see. So you can do it. The t half is given, and the amount disintegrated in 1 year will be what? Shanvi, you there? Shanvi, hello. Okay, just a minute. T half is what? T half is the time in which the number of atoms reduces to the half of its initial value. So n equal to n naught by 2, t equal to t half. Okay. Now we know the t half equation is t half is equal to 0.693 over lambda. Okay. Now this lambda we can calculate from this equation. That means lambda equal to 0.693 by t half. That will give us the value of lambda, and then we can put the value of lambda here. Time is 1 year, and then n naught is given to us. We can calculate the n, which is mass, and then we can subtract this from 1. So just for the sake of solution, I'm giving you it. You people are there or not? Okay, no problem. I am telling you the solution. Shanbi, Shamim, and Gauri. So I'm telling the solution. You there, na? Hello, guys, speak up. I'll tell you the solution. Don't worry. Okay, no problem. I'm telling the solution. So the answer is n equal to n naught e raised to power minus lambda t. Lambda t, we know this from t half equation. What is the t half equation says? T half is what? T half is equals to 0.693 over lambda. Okay, so from here lambda is equals to 0.693 over t half. From here you can calculate the lambda. Now if you will calculate the lambda, which is 0.693 over 5.27, and t is 1 year, you can directly put here. Okay, so if you will calculate n or m, it will come as e raised to the power this, which is 0.876 mg. Initially it was 1, finally it is 0.876 mg. So the total amount disintegrated will be 1 minus 0.876 mg, which is 0.124 mg. So the correct option is 0.123 mg. Guys, please respond. I mean, if it is not clear, then I can explain it again. If clear, then no problem. What to say? Gauri, Shamim, you can write in the chat box if you're not able to speak. I'm waiting. Is it clear to you people or not? The question is clear to you people or not? Okay, I'm moving forward to the next question. A sample decays to 1/60th of its initial value. If its lifetime is 2 years, therefore total time taken to reduce to this value will be what? And the options are 4 years, 8 years, 16 years, or 12 years. Okay, so if you will put this in the same equation, n equal to n naught e raised to power minus lambda t, so we can put the value of n naught as 1 by 16, and 1 by 16 n naught. Just just a, just a minute. Okay, so you people are there or not? As we can see, a sample decays to 1/60th of its initial value, and the lifetime is 2 years. Therefore, the time taken to reduce to this value will be what? And the options are 4 years, 8 years, 16 years, and 12 years. So, just directly putting this into the equation, initially we are taking as n, the final will be n by 16. Okay, so in this equation, if if we put n equal to n by 16 and this equal to n, we can directly calculate the time. So if the lifetime is 2 years given to us, which will be ln 2 by 2, the time comes out to be 8 years. Please solve it, and if you are not able to solve, you can write it to me and I'll tell you the solution. Now I have chosen certain question from the week 1 assignment whose solution I will be telling you, and if you have any issues then you can write to me. So how do we calculate the number of alphas and betas? I have already solved one question. This question in this question I have explained how do we calculate the alpha and betas, and still if you are not able to solve, then I can give you the detailed solution. So in the week 1, the assignment, the uranium with Z equal to 92 is decaying by a chain of alphas and betas and giving a final product as PB206 with Z equal to 82. So the number of alpha and beta emitted in this series will be what? Second question is in which group all the radioisotopes occur in nature, and the third question is which of the following relationship is correct. And the correct answers are 8 alphas and 6 betas, 237 NP, 226 Ra, 210 PO, 220 Rn, and the 9C is I equal to 2.303 over T half. Okay. Now moving to the next question, a flask has 1000 Curie activity of 60 cobalt. After 4 half lives, how much activity in Curie of 60 cobalt will be left in the flask? Second question is density of nuclear matter is what? Does it increase with mass number, it decrease with mass number, increases up to the mass number 60 and then decreases, or does not change with mass? The last question is saying that the average binding energy of nuclei, it increases with mass number, decreases with mass number, increases with mass number up to 60 and then decreases, or it does not change with mass number. And the correct options are the 10th. Okay, so all this I will upload in the video form, and still if you have problem then we can see. As you people are not speaking up, I don't know is it even clear to you or not. Gauri, Shamim, please type in the chat box. I will upload this recorded video. I will share the PPT with you people, and still if you have any problem you can write me in the email. And we have the class every Saturday from 3 to 5 p.m. and please ask other people of yours to join the class. In the live session we can have discussion. These discussion will let you solve the assignments carefully, and also you know you can get to know what kind of question you will be getting in the exams. So we can quit the class, Gauri, right now, and in this YouTube channel I'll share the recorded video. You can go through the previous questions solved, and still if you have any problem you can write to me. Okay, Shamim, Gauri, so fine for the day. Now I'm leaving. Okay, see you next Saturday. I hope you will join. So take care, bye, good learning.
Thank you, sir.